Hi friends, let's start indices and SURDS topic today. And what is an indices? When a number a and it is multiplied by itself n times, then the product is called nth power of a. Okay, it is also a multiplication type of problem. Okay, but here n can take any value. So it is written as a power n, where a is called base, n is called power. This complete thing is called indices. Okay, so how to call this a power n? It is called as a, which is base a, power n, or a raised to the power n. Both are same. Okay, so there are some laws for these indices, which are called as 7 laws, which I think everyone has learned in 7th class. Let me recollect those 7 laws. Okay, and how to remember them. Okay. So here a power m into a power n is equal to a power m plus n. What is the meaning of a power m here? A is m times now, and here a is n times now. So total, how many a's are there? So we have m times here, n times here. So total a is nothing but m plus n times. So when you are multiplying, the times gets increased. When you divide them, the times gets decreased. Here a is to the power of m, okay, and here a is to the power of n. Division is nothing but subtraction. Subtraction means it has to be subtracted. Multiplication is nothing but addition. Addition means it has to add. So here it is a power m minus n. Now a power m whole power n. It means that a is raised to m and complete a power m is raised to n. It means that it is again a multiplication concept. Multiplication and multiplication. So double multiplication. That's why it's called as a power mn. Mn. It's double multiplication. So you replace mn with mn. Now, if there are two numbers inside and we have total power as m, you can separate these numbers individually like this. Because here, the sign is multiplication here. When it comes to outside also, this becomes multiplication. It will be a power m into b power m. Similarly, if we have division here to the raise of whole power m, so same thing will be copied here. So each base whole power m divided by b power m. And this is universal, as everyone knows. Anything power 0. Anything power 0 is 1, but with one clause that a is not equal to 0. 0 power 0 is undefined. That will be discussed in the concept of functions. So here it is not required. So just remember that anything power 0 is 1 except a is not equal to 0. And here if the indice is in the denominator, this can raise it to the numerator with the help of minus sign here. If a is n times in the denominator, if it comes to a to the power of minus n times, the numerator. Let's discuss about SURDS. What is a SURD? When root of a number, if it is not giving exact solution, then the root of number is called SURD. What is it exact solution means? Exact solution means if it's not a perfect square or it's not giving a integer value, then we call it as SURD. Example here, root 4. Root 4 answer is 2, which is a rational number, which is an integer. So it is not a SURD. If root 2, if you approximate it properly, it becomes 1.414 so on. So which is not giving exact solution. So it is a SURD. And root 8 is also not a SURD. Okay. So whenever we are solving the problems of SURD, we require what is the order of SURD. So order of SURD. What is order of SURD? If a to the power of 1 by n. So here n is in the denominator part. Previously, when you learned about indices, n is on numerator part. Now here in the power, it is in denominator. It can be written as like this. You can take a root like this, and whatever is the n value, you have to keep inside this, not outside this, So this 1 by n can be written as n has to be inside this bracket and a. This is irrational. If it is not giving you the exact solution, then we call it as SURD of order n. Order here, n denotes this one. So here a is called as radicand and n is called as SURD of order n. Take an example here, 7 to the power of 1 by 2. So here 2 is nothing but order. Which order it is? 2 order. So it can call it as, it is SURD of second order with radicand 7. Okay. So whenever we have 2, that is quadratic order, no need to write 2 here. This is an exemption. Because normally it starts from 1, 2, 3. If you have 1, it doesn't have any value. So if you have 2, as it is starting here, we are not writing for 2. For the remaining numbers, for 3, 4, 5, 6, we will write it here. So whenever we have something whole to the power of 2, ignore writing 2 here, just write 5. This implies that it is nothing but 5 to the power of 1 by 2. If you have other than 2 here, if it is other than 2, that is order of 3, something extra, then 3 has to be denoted here inside this bracket, inside this root, and write it like this. This is the notation we will follow. Discuss about laws of surds. Okay. So as I told you already, this is order. Order has to be written here. If you remove this surd form, this order form, and you write it clearly, it becomes p to the power of 1 by m. If this same order is applied to two numbers which is inside, if you take these numbers outside because the root is common for both these numbers. If you take it outside, they will get individual roots, p to the power of 1 by m, q to the power of 1 by m. Similarly, here multiplication of two numbers are there inside this root. Now here division of two numbers are there inside this root. So that root will be again applied separately here, p to the power of 1 by m by q to the power of 1 by m. Now if you have p of the order m whole to the power of n, so it is again 1 by m whole to the power of n means it is nothing but multiplication of n times. So it is nothing but, so first replace this p to the power of 1 by m and keep whole to the power of n. So this is n time it is repeating, that's why this n gets multiplied here, it is p to the power of n by m. Now this same can be written in the other form. You can take in n here inside and whole to the power of 1 by m. So this can be written as m root of p power n. So it means that if mth root of p whole power n is there, this can be replaced with mth root of p, this n can go inside. Okay. If p is with the order of m and it has whole to the power of m, then it becomes, as p is with the order m 1 by m and this m get cancelled, it becomes p. Okay. Let's discuss about type of surds here. Okay. Let's see first about proper surd. If it is the factor of only 1, the surd is of factor 1, then we call them as proper surd. And if the factor of surd is not 1, then we call it as mixed surd. So here in front of root 2 we have 2 here. Here in front of root 2 we have 1 here. So it means that if 1 is there, it is called proper surd. If not 1 is there, it is called mixed surd. Like 2, 7, it can be any number. What are like surds? Like surds are used for comparing two surds. If two surds have same surd number, called as like surd. Here we have root 2. Here we have root 2. So though if they are, one is proper surd and another is improper mixed surd. So but as they have this common surd root 2, so we call them as like surds. If surds are different, here root 2, here root 3, then we call them as unlike surds. So if you want to apply addition or subtraction, the primary condition for applying addition or subtraction for surd is the two surds where we have to apply has to be like surds. Okay. So if it can be applied only for like surds. It is like this. Here 7 root 2 plus 3 root 2. Here surd is common here. So like surd, it is root 2. Then surd is common. Then this factor can be added directly. That is 7 plus 3, it is 10, and root 2 is a surd. We have to it come as this. Okay. When you apply subtraction also, as root 2 same surd is there. Okay. So only this factor has to be included. Like 4 minus 3, it is 1. 1 means root 2. Like this we have to do for addition or subtraction. Now, how to apply multiplication and division for two surds? So multiplication or division can be applied only if order of surd is same. What is the order of sum? If it is a mth root of a, here m is called order. There is nothing but a to the power of 1 by m. Here m is called order. This has to be same between two surds before you apply multiplication or division for them. So take an example here. Root 2 into cubed root of 3. So here, if you write it in the order form, it is 2 to the power of 1 by 2. 2 to the power of 1 by 2 here, and it is 3 to the power of 1 by 3 here. Here the order is 2, here the order is 3. When order is 2 and order is 3, we cannot multiply them directly. So we have to make them order same, then only we can apply here. So in order to make this order same, what we have to do? Here 2 is there, here 3 is there. So take LCM of 2, 3, or in order to, here 3 is there. So multiply 3 in the numerator and denominator, multiply 2 in the numerator and denominator, it becomes, so 2 to the power of 3 by 6 and 3 to the power of 2 by 6. Now this order is same. When order is same, this 3 can be taken inside. It is 2 to the power of 3, 6th root of 2 to the power of 3, 6th root of 3 square. This 6th root is same for this 2. Order is same now. So it can be taken as common. 2 cube means 8, 3 square means 9, 8 times are 72. It is 6th root of 72. So like this, if in order to apply addition and division, the condition is they have to be like surds. In order to apply multiplication and division, okay, the condition is order of surd has to be same. So let's see problem. Which of the following surd is greatest? Now to compare these four surds which are unlike surds, because here 2, 3, 5, 6, and its orders also different, 3, 2, 4, 6. For unlike surds, you cannot compare them. To make them as same order, then we can compare them. Okay. So here 2 to the power of 1 by 3, 3 to the power of 1 by 2, 5 to the power of 1 by 4, 7 to the power of 1 by 6. So we cannot compare these numbers unless the power of all these surds are power same. Here 3, 2, 4, 6 are the powers of these 4 surds. Take them LCM, you will get 12. So it means that in the denominator you have to get 12. Now to get it 12, what you have to do? Multiply 4 on numerator and denominator. So like this. Here, in order to make it to 12, multiply with 6 and divide with 6. Make it 12, multiply with 3, divide with 3. For 6, make it with multiply with 2 and divide with 2. Here, so 12 is the order. So take the 12 outside. And what is remaining? 2 to the power of 4. Here, if you take 12 outside, it is remaining 3 to the power of 6. Here, if you take 12 outside, 5 cube. If you take 12 outside, 7 square. Now all orders are same. All are in the order of 12. Now we can compare which one is greatest, because if orders are same, here we have 2 to the power of 4 means 16, 3 to the power of 6 means 729, 5 cube means 125, 7 square means 449. And which one is the greatest here? Obviously 12 power of 729, which comes from root 3. So this is highest here. Let's see the topic of rationalization of a surd. What is the rationalization of a surd? It is a method that is used for obtaining a rational number for a surd with multiplication of another surd. So it means that if you have surd, in order to get the rational number, if you multiply with another surd which is of opposite side, then that surd can become rational number. So that process is called rationalization of a surd. So take an example. If the question is 1 by 2 minus root 3. So here the surd is like this, 2 minus root 3 is the surd. In order to make this as rational, this surd as rational number, what we can do is, we can divide and multiply with opposite side. 2 minus root 3 means 2 plus root 3, 2 plus root 3. So this gets cancelled. This is just an alteration in order to convert this surd to rational number. So here, if you see only denominator part, 2 minus root 3 to 2 plus root 3, it takes the formula of a minus b into a plus b, which is equal to a square minus b square. So numerator will be like this, remains same, 2 plus root 3. Here it takes 2 whole square minus root 3. If it get cancelled, it becomes 2 plus root 3 divided by 1. Now the denominator which you see it as a surd, now it has become rational number 1. And the denominator which is 2 minus root 3, now it becomes 1. And the numerator which is 1, it has become surd now. So it is just a method of alteration. If you have surd in the denominator, you can move the surd to the numerator. If there is a surd in the numerator, you can move it to the denominator. In most of the cases, we require surd to be in the numerator, not in the denominator, for easy calculation purpose. So we use the concept of rationalization in order to bring this denominator to numerator. So normally you will see problems like this, where for a surd like root 6, something like this, okay, it gets on into root 6 plus root 6 plus root 6 and so on, and you have to arrive so on to infinity terms, and you have to arrive a answer here. So similarly like this, root 12 minus root 12 minus root 12 minus so on to infinity terms. So here plus and minus is there. Now if you have multiplication here, 7 root 7 root 7 root 7 so on infinity. So how to solve these problems? So normally the method is, consider this whole term as x and replace this term as x and do the calculation and solve the problem. But if you understand it logically, goes on, it has to arrive to a square, perfect square, and it is square root of a perfect square will give you square root. 6 is not a perfect square. In order to make this whole thing as a perfect square, how much I have to add it here? How much I have to add it here? So next nearest to perfect square is 9. So in order to become 9, how much I have to add? 3. So if I add 3 here, it becomes 6 plus 3, square root of 6 plus square root of 9, it is equal to 3. So answer is 3. Some people may say, sir, if you subtract here minus 2, it becomes 4, then that is also answer. Yeah, even that is answer. So we have two answers for here, 3 or minus 2. So simply same answer apply here. In order to make this as perfect square, how much you have to subtract from 12? So nearest perfect square is 9 here. So in order to make them, you have to subtract. That means you have to replace this digit with 3. So answer is 3 here. Some people will say, sir, if I add minus 4 here, already minus is there, minus of minus 4, it becomes plus 4, then also it becomes perfect square. Yeah, both answers. So the aim of these problems is to make them as perfect square. How much you have to replace here? How much you have to replace here? But not in the case of multiplication, because it becomes 7 to the power of 1 by 2 here if you replace this root, and again it is 7 to the power of root 1 by 2 and so on, and it repeats for infinity terms, and remember this answer is 7. So whatever is the x value, whatever is the value here, that is the answer here. And if you want expression for this, take it as x, square it on x, and take this as x, it becomes answer. Okay. So through process we can do, or without process, so whatever is the number here, just take that number as answer in case of multiplication. Okay. So like this you can apply shortcut logically. Thank you.
Please subscribe to my channel Connecting Minds for more videos, and please share link with your